Hey guys, today we're going to be working on our finishing up our earth layers diagram and poster. First period, I know at the beginning of the class yesterday your form for the lab wasn't working, so if you need to go back and double check that and fix that, then you're welcome to do that before you get started with your earth layers, but definitely make sure that you check that. If you got a really poor grade at the first half of class, that grade is probably changed because part of the form wasn't working properly, but it is now. For the rest of you, this is where we left off on our earth layers diagram. You should have everything colored. We colored our inner core, outer core, mesosphere, and asthenosphere all one color. We looked at our lithospheric plates and coated those a little bit more specifically, because it's important that we kind of understand the difference between our different types of crust, our continental and, continental over here and oceanic crust, and also that it's joined with that upper portion of the mantle that is a solid, right? So they move around on top of the asthenosphere and run into each other or move around away from each other and all that stuff. So that's kind of where we left off. So what you're going to do first is you're going to add some convection currents, because of course this whole idea of our plates interacting, our lithospheric plates interacting, is due to convection. There are some varying theories on how that convection actually works. Not too worried about that with 6th grade, but this kind of over here, this paragraph, if you want to read it, it gives you a little bit more information. These are some varying models. However you decide you want to draw convection is totally fine with me, as long as you get some done. So here is how I drew my convection currents between my mantle and or in my mantle between my asthenosphere and my mesosphere. So that'll be the first thing that you do. After you do that, you're just going to add labels for what you've done up to this point. It's important that you look at the rubric. So these arrows I actually colored and cut out from the paper that's stapled to the back of your rubric. Hopefully the sub has already given you the rubric with that those labels stapled to it. You don't have to use the labels and the images at all. Those are just optional for you to use. If you've already added some labels, you're welcome to leave those there and work with what you've already started. So if after you add these convection current images, you want to start looking at giving your poster a title and looking at the information on the layers that we've covered. So you need some titles for your physical layers, some information for your compositional layers. Make sure you're looking at the rubric for everything that needs to be there. You need of course, a big title across the top and a subtitle. So you can see here, these are two different ways that this can be met. The expectations can be met. So everybody's doesn't have to look exactly the same. This one has the information kind of written on the outside going around the image. This one has a key that condenses everything and then some labels on the actual picture that you colored. You can do it like one of these, or if you've already started something and you just want to add some information based on the rubric, you can do that. Remember, for example, here the asthenosphere is identified as being a semi-solid because that is what we're talking about with our physical layers. So there is some information on the rubric that's asking you to be specific about some information. There are some labels that you're adding, so that's the little extra information for each label. So look at that, get all of your earth layers, labels, and your subtitle completed. Once you do that, then you can move forward to the plate boundaries. So if this is a nice little review of what we learned in our lab, the 3 different plate boundaries. So remember, our transform boundaries slide and cause earthquakes. Our divergent boundaries divide, so they move away from each other. and that's where we have our mid-ocean ridges and our rift valleys, and then convergent boundaries collide, and that's where we have ocean trenches and mountain formations, and sometimes a combination depending on what kind of convergent boundary there is. Your handout has got some diagrams that I definitely want included on your poster. So you can either draw those diagrams or you can cut out the ones that are already drawn for you. But what I mean by those pre-made diagrams, the ones that look kind of like these. So in addition to our big drawing, these kind of from above view versions are a nice supplement to look at different ways that those boundaries can be depicted. One thing that's important for you to know is there's not just two different kinds of convergent boundaries, there's three. In our lab, we looked at convergent boundaries, the bottom two, so the continent, ocean, subduction. So that's when the oceanic plate collides with the continental plate, and we have the mountain form and the ocean plate subduct. And we looked at continent to continent to where they kind of crumpled up on each other and mountains formed. And there is a little bit of subduction with that as well, but it's mostly kind of building up because of the equal density. The other thing that can happen is ocean to ocean. And in ocean to ocean, you still get a trench, and then you sometimes do get mountains, which are going to be islands that come up from below the ocean surface. And since those are both really heavy, dense plates, the more heavy, more dense plate is going to be the one that sinks. And in fact, the deepest part of the ocean is one of those types of plate boundaries. So the Mariana Trench is where two oceanic plates collide and one subducts underneath the other. And we'll look more at that next week. The last thing that you need to know about before you start your final set of labels is about hotspots. So a hotspot is where islands form, not necessarily at plate boundaries, but in just the middle of a plate somewhere where the lithosphere is a little bit weak, or there's an extra hot plume of magma coming up from the mantle that causes an underwater volcano. And an underwater volcano turns into a mountain, and the top of that mountain is an island. So an island chain actually comes from the combination of the hotspot and the movement of the tectonic plates. So we now know that tectonic plates move in certain directions, and that's how we have all of these islands in Hawaii, right? So you can kind of notice that the furthest islands away are the smallest islands from the hotspot. That's because this island was formed over this same exact hotspot, but the plate has moved and that island has eroded over time. So it's gotten smaller and smaller and smaller, and our largest island, the Big Island of Hawaii, is still currently over that hotspot and an active volcano. So there is a hotspot on your diagram, and so you want to make sure that you label that and give some information about what a hotspot is. So these are two different examples of what your final poster will look like. I have a big overlying title with two subtitles, some information about those subtitles, and then some information about my labels, a little bit less information, but still information about those labels. So this is the one that I made that's going to be on the board. This is just a digital one, and yours doesn't have to look like mine, either one of mine. It can look like your own creation as long as that it meets all the requirements of the rubric. The requirements on the front and the back of the rubric, so make sure that you turn it over to make sure that you have everything that you need to have. I will see you guys on Monday. Have a great weekend.